Hi, class. I just had to say that, actually, so here it is. I'm making this video just for you guys because as just a thank you, because my appreciation for what you all have done in the last discussion is more than I just wanted to put in an email. I wanted to just see my face, hear my voice, so you could actually feel and hear my appreciation. Now, what I did is I gave you all an impossible task in some ways. You know, I gave you an article that well beyond you know, anything that I could have expected anybody to technically really grasp. And I did it with a purpose, though. Now, what I saw is I saw people reaching. That's the coolest thing. I saw people reaching. I could tell people read it, read the article a few times, were just digging and pushing and pushing and pushing. That right there is why I'm saying thank you so much, because that is actually not just a service to, well, to the class, and I saw the discussions. Some discussions were incredibly insightful. It also just actually serves you. So, and here's how, okay? Because you might be feeling a little bit disheartened. That's partly why I'm making this video, is I don't want you to feel that way. I want you to see that there was value in pushing yourself, even if you felt like you didn't make it all the way to where you wish you would have made it. I'm sure you're used to reading stuff and having it all sink in and it didn't get there. So you might have felt like you failed. That's not true, okay? You gained, you definitely gained, okay? Anytime you push yourself, you gain. Now, how you're gonna gain is, you know, it's basically, well, let me just give you the insight. When you go on to like PhD work, it's pretty much all you do. You're constantly like well beyond your limit, and you're constantly scratching and digging and feeling hopeless about things and about life most times. But out of that process, you actually learn that eventually you'll look back and say, wow, I can't believe that how far I've come. I can't believe where I've gotten. So here's the thing. If you keep reaching up high, you know, I wanted to give you something that was high. If you keep reaching and reaching and reaching, eventually you'll get there. I promise you. That's the whole point, is that you only fail when you stop trying. That was kind of like a lesson, okay? Now more as far as the applications of everything go, I wanted to give you all just a very quick kind of overview of some of the key topics, because you heard some topics like endogeneity, these type of things being tossed out there. So I wanted to give you just a little bit of a background, since you don't have it in a textbook or anything like that. You may have not been exposed to it. So I'm going to go back to a paper and a cooler. There we go. Okay, so if I have a standard equation. So first off, when we're doing linear regressions, you can think about this as a variable y, a variable x. In this case, we're looking at demand. So we're going to have maybe like prices and quantities. So you can get prices and quantities of data, right? That's something that all firms track. I mean, everybody tracks prices and quantities of stuff sold. So that's data that every firm has, and so we might sort of look at price and quantity, and you might find that there's say like a data point. Okay, so this data point representing a certain price level and of a certain quantity of, say, goods sold. Now, if you looked ahead at your data science project, or the I call it case 2, you'll see that we're looking at price and quantity of soda data. So every one of those data points is a point of price and quantity for soda sales. Now, the thing that we don't see, and this is where theory comes in. So this is what we see. Now in economics, you all see supply demand curves. Probably you've seen that. So supply curve maybe going up, demand curve coming down, okay? Now, these are theoretical curves. So these curves actually don't exist in a hard reality. These are theoretical curves. You can build them mathematically, all kinds of different ways. But they're theoretical curves that you see in all your economics textbooks. Now, the reality that is what these curves are trying to show you is that they are determining prices and quantities of things. So it's this equilibrium dynamic of free markets that gets us to equilibrium prices and quantities. Okay, but just remember that in your data and actual applications, what you have, there's P is Q, what you'll have is a singular point of data, okay, for for a given product on a given day. You'll have a price, the average price that's sold, you'll have however much it's sold on that day, something like this. Now, you see that there's reality, there's theory with supply and demand. And so how does this all fit into when we started to estimate these things? Well, if I just if I started collecting, say, a bunch of data points for, say, like one product over several different days or months or something like this, and I might have, like, in June, like, the price fell, but there's a higher quantity. Maybe in August, prices were up, less was sold. It was something, and I just started collecting data, okay, on prices and quantities. Okay. You might end up with something that looks like this. This is called a scatter plot, by the way. It's a scatter of different points in two-dimensional space. And every one of these is just a price and a quantity pair, maybe for like sales on a given month or a given day, something like this, right? Now, statistically, what we have with linear regression is, linear regression seeks to fit a line to characterize a set of data points, a line or a plane. I'm going to say a line because we're doing two-dimensional space. If we're in three-dimensional space, we'd have a hyperplane. Well, let's just start with a line. I think it's the easiest. So the regression line is going to give you, if I look at this, I can see that it looks like there's this negative kind of relationship. And so without getting into the technical details, the regression line is going to fit this data point. And it's going to give you an estimate. This will be, since this is my y-axis, this will be a p hat. This is my estimate. I won't get into how they actually solve that. That's more of a statistics thing. I hope everybody had at some point. And if not, you can feel free to reach out or talk, or you don't really need to know too much about it besides what we're talking about here on a high level. But you can see that this line, this sort of p hat, is a function of q. So this is a function of q, and it's a linear function. So you remember the slope is point slope, or the formula for a line is y is equal to mx plus b. Here I've got y is equal to m. What's m? M is the slope. Okay, we're going to call those it's just a coefficient. Instead of an m, let's do beta q. Okay, and then x is q. So there's my mx. Plus b is my intercept. I'm going to put my intercept in the front. I'm going to call that beta naught plus beta q, q. Okay, this is my statistical model. I've got my coefficients. I've got my x data point. I've got my y, and I'm saying y is a linear function of x, and then the coefficients define that line. Okay, so that's what we have there. Now, what I would like you to think about, what we're doing when we're talking about elasticities. Okay, so remember, elasticity of demand. This is going to be this percentage change in quantity for a given percentage change in price. That's my definition of elasticity, right, of demand. And so look at implicit in this. Look, it's if I change my price by a little bit, how's my quantity going to change? Obviously, that's a very important metric that we're sort of looking at, and it tells us a lot. We want to, there's so much. If we really know elasticity, we really are confident about this metric. That's really at the heart of so much, revenue and price optimization problems, is trying to get this elasticity measure. But implicit in this relationship is causality versus causation. Look, if I change my price, how much will my quantity change? That's a kind of a causal and causality type relationship. You see that? It's that kind of causality type relationship. So we want to talk about causality and with elasticity. This is what we want to talk about. Okay. Now, when we go pull price and quantity data, this is what we have. Okay. So, oh boy, we might have an issue here, huh? We might have an issue here. Why? Well, actually, and because actually I need to change my, so I need to do an inverse demand function actually to do this more appropriate, maybe to be more in line with the book or more in line with the paper, because it doesn't really change much. You put Q's in. This is how we typically graph it theoretically, P's and Q's, but actually to calculate elasticity, we're going to probably want to have our dependent variable is Q up here. See, so we're going to want to rewrite this equation, Q hat, and flip all this and do an inverse demand. Beta x plus beta p like this. Just flip the equation, flip the stuff. This is how textbooks are going to draw things: price, quantity, price, quantity. But we're thinking about the effect of a change in price on the change in quantity. So we were thinking about quantity being our dependent variable and price being our independent variable, statistically speaking. So we just rewrite it this way. Hope I didn't confuse people too much. It's not a big, we haven't really changed really much of anything. So it's not a big dramatic change except how I'm writing it. So the slope, now looking at the slope, this beta p, okay, the slope, so I can draw this again if you want, if it helps, if y'all don't want to do a mental gymnastic and flip the axes, I can just do an inverse demand like this, okay? We'll still get this negative relationship, and we'll get this beta p as a slope, right? So the slope when we look at it, it's like, well, if I change, remember, rise and over run, rise being Q over run P. So that means, you know, if I'm changing my P, how much is my Q sort of changing? That is starting to look kind of like an elasticity measure, a little bit, right? Right? Y'all kind of follow that, I hope. That's starting to look a little bit like we're getting into the realm, because remember, rise over run is my slope. What's my rise? It's my delta Q over delta P. This isn't quite the same because elasticity is a percentage change in quantity, whereas slope is just a change in quantity. So it's we can actually dig that out not too hard with just a little tiny bit of other things. Actually, very simply, putting these in natural logarithms does that trick. But anyway, we don't need to dive into those details. The details I really want you to see is that slope here sort of looks almost like an elasticity measure. And so really kind of what we could think about is, okay, well then, why don't we just say slope is the elasticity? I mean, if I put this in logs, so if I were to go ln, the natural log of Q is equal to beta naught plus beta p ln of P, then the interpretation on beta P now would actually be as a percentage change. And so I'd almost have like an elasticity interpretation. But that's I say an interpretation. Is it, what can I call it, elasticity? No, I cannot. So here's the thing, is you can't just do a regression and plot the coefficients and call that elasticity. Why? Because this right here is going to be not causal. This is just a correlation. This is a correlation relationship. When I do a simple linear regression, it's a correlation. It fits a line. It's a correlation kind of measurement. Okay, not a causation. Why is it not a causation? And that's kind of the big point, the big question here. Why not a causation? Well, the big overarching reason why is this big word called endogeneity. Oh, there's a big technical word. Okay, endogeneity. Okay, that's the technical word. The two forms that we're going to really think about are going to be so endogeneity, first off, is going to be generally a problem for us when we want to make causal statements. In this case, how much does my quantity change when I change price? Elasticity measurements. So when I want to make causal statements, then endogeneity is going to be the monkey wrench here. And this monkey wrench is going to take kind of two main forms. First one is going to be called the omitted variable. Omitted variable bias. Bias means that this coefficient that we get out of our regression is actually not the real coefficient. So bias means that we're getting the wrong estimate here. Okay, that's what we mean by bias. Now, how do we get that? Why? Because actually there's an error term in all this too, in all these statistical models. So all these statistical models, you've got Q, or you got your Y, and you've got your X, and then your sort of your line. The thing that makes it a statistical model is that there's error. Error is going to be observed by, so if this is my line, what's the error? The error is just the distance. So for a given X, so take this Q here. Take that Q. What did it predict? This line predicted that my P would be way up here, right? But the actual P was down there, you see? So this distance is my error. And similarly, there's my error here, and there's my error there. For that point, here's my error. My line is making all kinds, it did perfectly for this point, pretty close for that point. This point has got some error. You see, so every statistical model is going to have this error term. Okay, I want you to consider something. Look, whatever we don't put into our model, whatever is not actually explicitly written into our model is automatically just baked right into that error. Okay, so in terms of we change price, how does quantity change? This could be seasonality, right? It could be there's different seasons. It could be that we're not accounting for seasons here. We just said price, quantity, okay, this relationship. We didn't talk about seasons. We didn't talk about was there a sale of something else going on in the store? Is it a holiday? Is it particularly hot outside today or rainy? I mean, that might affect your elasticity of, say, umbrellas. Can you imagine that? Okay, all these different kinds of things. There's a lot of things that could go into this equation that we're not accounting for, and all of those unaccounted things are falling into that error term. And if those things are actually important things that we're dropping out of there, then we've got omitted variable bias, which is a form of endogeneity, and that breaks our causal relationship and destroys the estimate that we get right there. Okay, that is endogeneity, monkey wrench form number one. Okay, the second type of endogeneity we're going to get is going to be called reverse causality and simulteneity. Okay, reverse causality, and I'm just going to lump it with simulteneity here. We can see simultaneity as this. Look, prices are determined by all these things on the demand side, right? And this looks like a demand line, does it not? But every one of those points wasn't just determined by demand, it was also determined by supply side factors. You see, a price and quantity is just this combination of supply and demand side factors. Therefore, we have supply and demand baked into that price, okay? So what is it? Are we looking at the demand side? Are we looking at the supply side? It's not obvious, okay? So that's sort of the simultaneity issue. We can also think of reverse causal. I put them in there. Actually, maybe they shouldn't be so lumped in, but I put them in. We can also think of another problem being, sort of a chicken or egg problem. That's sort of this reverse causality that changes in quantities can affect changes in prices. Changes in prices can affect changes in quantities. There's these two directional, bi-directional causal type relationships, and there's also simultaneity, and there's other factors of omitted variables, all of which are causing endogeneity, which have the effect of messing up our coefficients if we were to just do a very simple, naive linear regression. That's the point. Okay, now everything that the article's talking about are different kinds of fancy tricks and ways and mathematical tricks and ways to try to address this problem. Okay, I've actually got ways that are not in there that I created, I think do a better job. Personally, I like the way I do it more, but there's all kinds of ways to skin a cat. And that's where the technicians and econometricians and the statisticians and everybody else sort of gets paid their bucks, is trying to figure out this problem. Now, the reason why you should, the things that you should know is, one, what this problem is, how it exists, the difference between causation and correlation. We're getting into the realms of statistics, and it can become very easy and very hazardous to go, oh, look, these are all downward scattered plots. There's obviously a clear negative trend going down between these two relations. So obviously I'm looking at a demand curve here, right? And I can just maybe estimate that and get my coefficient from just doing a very simple linear regression, which I could do in Excel, and get a beta coefficient, well, inverse demand, okay, beta coefficient, and maybe throw it in logs and come up with an estimate that I think is going to be, my causality, my causal elasticity metric. That would be hazardous. Okay, and how hazardous? It can actually be extremely hazardous. So, so the thing is that you need to understand these things at least the high level, okay? Because the people who are going to be doing the technical heavy lifting of this stuff, which may be you someday, but those folks are going to be trying to address these problems, and you need to at least know what kind of problems they're trying to address. We can dig into this, which ways are better, and talk about all that stuff, and if you want to. But at the very straight level, we need to understand the big picture problems. Now, also, we need to understand this because we're going to be doing, you're going to be playing with some price and quantity data. So this is where it kind of ties in. And unfortunately, like I said, I don't have a text for you all. I tried to give you all, so the methodology is I tried to give you all a chance to reach and push and see, and really kind of like, I thought, well, that was a chance for you guys to really go out and try to see and just really push yourself beyond like where you thought you might have ever been trying to push before. I know that can be frustrating as all heck, especially if you feel like you failed, but I want you to let you know you did not fail. You did not fail. Nobody did. You all, as long as you kept pushing and you read it and you pushed yourself, I guarantee you got something out of it. It's sort of like if you were to go run the Boston Marathon. For me, I'm trained. Okay, so if I'm not trained, I'm not trained. You all aren't trained economists. Okay, so that's fair, right? Right. So if I didn't train for the Boston Marathon and I went out and I went to run it, and I didn't finish the Boston Marathon, would I have gotten no gains? Think about it. Of course, I would have gotten gains. Just being there and pushing myself and running. Like I'll bet you. You don't see these things, but there are gains. And what I'm really trying to show, what I'm trying to actually impress on everybody, is if you really have a desire to be technical, then just keep, or anything you want to reach for anything, set the bar high, keep reaching. Okay, shoot for the moon, what they say, because if you miss, you'll end up amongst the stars. It's very true. I saw that saying hanging in Georgetown as an undergrad, and it stuck with me. And I did. I shot. And I'll tell you what, stuff that I look back at now, I'm like, oh yeah, this is cake. Used to just like freak me out a long time ago. I think, oh, I'll never learn that much. No, I'll tell you what, keep setting the bar, keep pushing, keep pushing, keep pushing, keep pushing. Okay. And that's what I was so happy to see. That's what made me so proud of you guys. That's what really made me so proud of you guys today. As I saw that in your discussion post, I saw you guys who were pushing. So thank you. And thank yourself, pat yourself on the back, right? All right, that's it.